What is up, guys? Xavier Elon here. I'm prepping for interviews, so I'm doing a lot of LeetCode videos, so please subscribe to my channel if you haven't already. I'm going to be posting fairly frequently. Today I'm going over search and rotated sorted array. So the description reads, suppose an array sorted in ascending order is rotated at some pivot point unknown to you beforehand. Basically, they just move like the elements along spaces. You are given a target value to search. If found in the array, return its index, otherwise return -1. You may assume no duplicates exist in the array, and your algorithm's runtime complexity must be in the order of O log n. So right here, when I see O log n, I immediately think binary search, so that should be a huge hint. So the examples they have here is the target is 0. So they're returning the 4th index, and target is 3. There's no 3 in here, so they return -1. So the way I solve this is basically we want to calculate the mid. Sorry, my dog's going crazy. Calculate the mid. So if the target is 3, we're going to calculate the mid by doing mid equals n plus start divided by 2. So we're going to get 7 plus 0 divided by 2 equals 3.5. It's going to be an int, so it's going to round up to 4. So that's going to give us the mid of right here, the 4th index. That's just how it works. And then we're going to check to see if start is less than the mid. Then we know that this part of the array is sorted, but that's not the case. Start is actually greater than, so it's greater than, so it's not sorted. So we're going to not check that one first. And we're going to see if mid is less than end, which it is, so we know this is sorted. And then we're going to check this to see if the target's in there, and we're just going to keep doing that. So that's how I solved it. So let's code it out. Hold on. So we have start is 0. And then int end equals nums dot length -1 because of 0th index. And we're going to have our mid. We're not going to initialize it yet. So we're going to do while start is less than or equal to end. So we're going to loop through all the indexes basically. And if nums of start is less than nums of mid, then we know the start to end is sorted. So that's what this means. And that's where we're going to want to check for the target. So then we're just going to check for the target. So if nums of mid is oh, and I forgot to actually, the first thing we want to check is if target equals nums of mid. This is what we're checking for. Then we're returning the index. Let me move this over here. Return Alright, and then back if nums of mid is less than or greater than the target, and nums start is less than the target, less than or equal to the target. That means target is in that sorted array because it's mid is greater than, let me show you on my iPad. Mid is going to be, so it's going to be, let's see. If we do this one, this is going to be the mid start. So we're going to be checking this array because it's sorted. Target is 3. So we have, move this over. We have nums of mid is greater than the target. That's true. 7 is greater than 3. And then nums of start is less than or equal to the target. Well, yeah, it is. It's equal to the target. So that still holds true. And if that's the case, we're going to adjust the high to, because we know, now we know the target is in that array, that portion of the array. So we're going to do end equals mid minus 1. And then else, that means if the other case is the target is in the other side of the array, so we're going to do start equals mid plus 1. And then we just have an else. So it's just basically the same thing except flipped. So if nums of mid, all over the place, is less than target, and nums of ends this time is greater than or equal to the target. And the reason we use add the equal sign is because it's never going to equal nums of mid because we already check it up here, so we don't add that, but we do add it for here because it can equal it. Like I showed you in the last example, the start did equal the target, but we're returning the mid, we can't return the start. So so in this case, we have to adjust the, let me show you on my iPad. In this case, we have to adjust the mid. So we're moving the start, I'm sorry. We're going to move the start to mid plus 1. So start's going to go here, end's still here, and we do for mid is, and so 7 plus 5 divided by 2 gives you a 12 plus, or 12 divided by 2 is 6. So this is the 6th index. So this is going to be the new mid. Yeah. And that's the case for a different target. If we had a different target number, I know I wrote target up here, but I was just showing you guys that. So hopefully that makes sense. And so, like I said, we need to move start in this case. So we're going to use this same statement. The statements are just going to be flipped because the target's in this part of the array instead. So, and then else end equals mid minus 1. Because if the target isn't in that, then it's in the other part. So we're checking these sorted arrays because that's what we need to check. And yeah, that's about it. And then if the start ends surpasses the end, we kick out of the while loop, that means we did not find the number. So let's return -1. And let's see if this works. Oh, and I did not calculate mid. That's dumb of me. And divided by 2. Alright, so yeah, this is the correct code. This is actually going to work. Oh, sweet. Alright, and then the running time is like it even says in the description, O log n, so that's binary search, that's why that's that. We didn't have to create any data structures, so the space complexity is O of 1, it's constant. And that's about it. Please subscribe if you guys haven't already, and thanks for watching. And if you guys have any questions at all, please just don't hesitate to contact me. I will love to answer any questions. And if you guys have any problems you actually want me to post videos on, let me know and I will do that as well. So thanks for watching.